Here we can see the schematic diagram of word current relay. This relay is connected directly, not directly with the line, but the current is being stepped down to some value and then it is fed to this relay. Basically, the relay rating, as I've said, is around 1 ampere, 5 ampere, but the current which is flowing to the line is obviously is very high, in the range of 100 ampere, 1000 ampere. In case of the fault, it may be more than 2000, 5000 ampere, like that. So this relay cannot be directly connected with the line. So we have to choose a suitable city where the current is being stepped down. Here we have taken 500 is to 1 GT. If 500 ampere current flows to the primary, in the secondary it is 1. Okay, so in case of any fault, if the current flowing in this line is 1000 ampere, then obviously the current here will be 2 ampere. Okay, so in this ratio it will be reduced. Now let us have a look on this relay. This is the relay setup. Now one electromagnet is there, which is this is one pole, this is another pole, and if the current flows through this coil, then flux will be produced in the main limb, and it will be divided into two parts. Suppose one is phi 1 and another is phi 2, and it flows through this path, and ultimately these two fluxes will be added, and ultimately it is the total flux. Now intentionally we are providing two rings in this two pole, so that there will be some phase difference between this flux 1 and flux 2. If the flux phase difference becomes 0, then no torque will be produced. So intentionally we have to provide this band. These are known as the band, made of copper. So copper band are intentionally fixed on this pole to provide some phase difference with respect to the flux of the other pole. So the torque will be produced, and if this torque produced becomes more than the torque provided by the spring, two springs are there connected at the up and bottom. So if this torque, that is uh, deflecting torque, we can say, if it is greater than this control torque, then the disc will rotate. And it is so designed that in terms of Ni, there should be constant in Ni. This should be maintained to rotate the disc. Ni, number of turn into ampere. So suppose this is the rated. If the Ni here, magnetic force, if it is greater than this value, then the disc will rotate. And suppose, as I have already said, if it is, suppose, let us consider this as say 100 Ni. Okay, now this 100 ni can be achieved in different way. 100 can be achieved if the number of turns here, say, if the number of turns here, say, it is say 200. 200 is the number of turn. Then this 200 multiplied by 0.5, that is also, that gives you the 100. If the current here is 0.5 and the total number of turns are used, then 100 ampere turn is achieved. And in that case, the disc that is made of aluminium, and this disc will rotate. And suppose if we set at 0.5 ampere, that means the current in the secondary, if it is greater than 0.5, 0.5 is the threshold, and we have to connect this pin here. So we have to connect this pin here, means we are using all the number of all the turns. So this 200 turns multiplied by 0.5. If it is greater than 0.5, then obviously it is more than 100 ampere turn. Okay, so 0.5 is the threshold value. So in the relay, this 0.5, 0.75, 1 ampere, 1.25, 1.5, 1.75, 2 ampere, this will be written. Okay, so there are 7 such flux settings. So we can set at any of these values. We can set at 2, we can set at 0.5. How it is being set, depending upon this ratio, this product. So I can make this 100 in different ways. Say 0.5 into 200, that is also 100. Then 1 into 100 is also 100. So if I make the number of turn just half, so if I make it is 800, then obviously this 1 into 100 will give the same ampere turn. So 1 ampere, 1 ampere or more than 1 ampere flows, then 100 will be achieved. Okay, so in this way, these flux settings are designed. So basically, current is not the factor. Basically, the number of turn is being varied, so that the number of turn multiplied by this threshold value equals to 100 ampere turn. Now, suppose we are connecting this pin here. This is a pin. The top of the pin is made of plastic. You can easily fold this pin, and you can easily insert this pin in this position. So it will be properly fitted at that position. So what will happen? The current will come here and it is connected to this. So all the turns are used. Then current is flowing to this coil. Then it goes back to this point. Okay. So when the 1 ampere is being set, then this plug position should be here. So in that case, see, the current is coming here, then it goes through this path. So it is just avoiding the upper number of turns. So in this case, 100 turns are being avoided and rest 100 is being used. So that is, if 1 ampere current flows, then 1 into 100 again 100 ampere turn is achieved. So obviously, if the current is more than 1, so the relay will operate, means the disk will rotate. And what will happen if the disk rotate? Now, see here, the disk is attached with this spindle, and it can freely move or rotate. As a result, at the two ends of this spindle, the jewel bearing are connected. Two jewel bearings, one is attached at the upper end and another at the lower end, so that it can freely rotate. Obviously, it should satisfy this thing, the ampere turn. Okay. Now, see, one arm is connected. It is fixed with this spindle or this needle, spindle. Okay, and at a distance here, two metallic contacts are separated by some distance. So it is normally open condition. Now, if the discs rotate, this contact will be moving in this way, and it will take some time to reach that position. And when it comes here, this contact will be made. So if this contact made, then current will be flowing through the trip coil, which will activate the circuit breaker. Okay, so circuit breaker will, there will be another arrangement which is circuit breaker. This component, the function of this component is to open the circuit from this bus. Okay, so that this fault current cannot flow anymore. Now, obviously, the ampere turn or the torque is fully dependent on the current. We know when we studied measurement, then also we studied this thing. Now, more the current flows the secondary, or the more the fault current, more will be the torque, and it will take less time to reach to this point. So I can set it, say, 0.5. Now, if the current here 1000 ampere, so the current here will be 2 ampere. If the current in the primary circuit or the fault current is 1000 ampere, then the current in the secondary, or we can say the current in the relay coil, is 2 ampere, and we have set it at 0.5. So 2 is more than 0.5, so it starts rotating. But at which speed? That depends on the ratio between these two, 2 divided by 0.5. How many times this current is more than the setting value? The 2 divided by 0.5, which is equal to 4. 2 divided by 0.5 is 4. It's known as the flux set.